Welcome to the deep dive. Today, we're really getting into CIS-EM practice questions,
That's right.
but not just the questions. We're aiming to pull out the core ideas of good IT event management.
Yeah, the practical stuff.
Exactly. So we have these practice questions, the answers, the explanations, and the idea is to translate that into, well, usable knowledge about managing IT events better. Less jargon, more why it matters.
Makes sense. It's about connecting those specific answers to the bigger picture. These questions, they're like little snapshots of real challenges.
Right.
And understanding the why behind them helps you see how something like ServiceNow, for example, helps you manage things proactively, not just reactively.
Okay, let's jump in. First one up. What is the main role of a connector definition in event management? And the answer given is A, to define how events are pulled or received from external sources. So getting data in, basically. What's the big deal about these connector definitions?
Well, think about your IT environment. You've probably got loads of different monitoring tools, right?
Sure.
And they all speak slightly different languages, technically speaking. A connector definition, it's kind of like setting up a translator and a specific mailbox for each one.
Okay.
It tells your main event management system exactly how to listen and receive alerts from that specific source.
Yeah.
It handles the protocols, maybe security details, the exact address.
Yeah.
All that stuff.
Uh-huh.
Without them properly set up, the system's deaf.
Yeah.
It just wouldn't get any information.
So it's like having, I don't know, a fancy control center, but no cameras feeding video into it. You're blind without the connectors.
That's a great way to put it, yeah.
Yeah.
It's absolutely fundamental. Step one, you could have the smartest rules engine in the world, but if no data is coming in.
It's useless. Got it. Okay, question 2. When using event rules, what component allows dynamic data parsing from an incoming event payload? Answer: D, transform function. Dynamic data parsing sounds a bit technical. How would you explain that simply?
Right, okay. So an event comes in, right? The raw data, the payload, it can be messy. Just a big block of text or data points, maybe formatted weirdly, depending on where it came from.
Mm-hmm.
A transform function acts like an intelligent sorter. It looks at that raw data, picks out the important bits like the device name, the error code, the severity, and then, crucially, it puts them into a neat standard format.
Ah, okay.
The dynamic bit just means it's smart enough to maybe use different sorting rules depending on what kind of event it is.
So it's translating chaos into order, basically. Taking all these different ways of saying something's wrong and making them consistent so the system can actually understand.
Precisely. That consistency is absolutely key. Without
Yeah.
that transformation step,
Yeah.
you just have alerts that are hard to read, inconsistent reporting. It makes everything downstream much harder.
Right. Turns noise into something actionable.
Exactly. Actionable intelligence.
Okay. Question 3. Which platform feature is used to visualize dependencies between services and CIs affected by an alert? Answer is B, Service Map. This one feels important for understanding impact.
Oh, it is. Hugely important. The service map, it's basically a dynamic visual chart of your IT stuff.
Like an org chart for technology.
Kind of, yeah. It shows how servers, applications, databases, all those configuration items or CIs connect to each other and how they support the actual business services.
Okay.
So when an alert pops up on, say, a specific server, the service map immediately highlights it, but also shows you what services rely on that server. You see the potential ripple effect.
So instead of just server X is down, you instantly see server X is down, and that's likely affecting our online store checkout process.
Exactly that. It connects the technical event to the business outcome, and that helps everyone. Tech teams, managers, even business folks understand the real priority and impact.
Makes sense. Helps you know where the fire is really burning.
You got it. It's your blueprint for troubleshooting in a complex environment.
All right, question 4. What happens when an alert is suppressed by a correlation rule? The answer given is C. The alert is not processed further and does not trigger actions. Now, suppressed sounds like we're maybe sweeping things under the rug.
Yeah. It can sound that way, but that's not the goal. Good correlation rules, they're designed to reduce noise, not hide problems.
Okay.
Think about it. One network switch fails, right? You might suddenly get alerts from every single server connected to it.
Oh, yeah, an alert storm.
Exactly. A correlation rule can recognize that pattern, lots of alerts from related devices in a short time, and it can suppress the secondary alerts, the symptoms, letting you focus on the primary one, the root cause, on the switch itself.
So it's noise cancellation for alerts, stopping you from getting flooded by 50 alerts when only one really matters for the fix.
Precisely. It combats alert fatigue. lets the team focus, of course.
That was a catch.
Well, you have to define those rules carefully. Poorly configured rules could suppress something important, so it needs thought.
Right, balance is key. Okay, number 5 takes us into proactive territory. Which field in the operational intelligence metric definition determines when to generate an anomaly? Answer: D, baseline range. So what's this baseline range doing for us?
Okay, so operational intelligence, or OI, is about letting the system learn what normal looks like for your key metrics. CPU usage, network traffic, response times, whatever.
Mm-hmm.
The baseline range defines that normal. It's not just a single number, but a range. Maybe CPU usually sits between 10% and 40% on this server at this time of day. The system learns this over time.
Right.
If a metric suddenly jumps outside that learned baseline range, even if it hasn't hit some hard-coded critical threshold yet, OI flags it as an anomaly.
So it's like an early warning, something's acting weird, even if it's not technically broken yet.
Exactly. It's detecting deviations from normal behavior.
Yeah.
This can catch problems before they cause a full-blown outage. It lets you investigate potential issues much earlier.
That feels like a smarter way than just waiting for things to hit a red line.
It is. It's moving towards prediction and prevention.
Cool. Okay, question 6. What feature enables the automatic grouping of alerts from the same device and similar symptoms? Answer: B, alert correlation rule. Hang on, we just talked about correlation for suppression. Now grouping.
Yeah, correlation rules can do both, actually. It depends how you set them up. Suppression, as we said, hides redundant alerts. Grouping brings related alerts together.
Okay, so how's grouping helpful?
Well, imagine you get several different alerts from the same database server around the same time, maybe high CPU, slow query response, low memory.
Right, all pointing to a problem there.
A grouping rule can automatically bundle these together under one parent alert. So instead of seeing 3 separate alerts, your team sees one issue for that database server, with the others nested underneath as related symptoms.
So it gives you a cleaner view. One problem, multiple symptoms, all packaged together.
Exactly. It clarifies the scope of the issue. Much easier to investigate one grouped alert than chasing 3 individual ones that are probably linked anyway. Streamlines the whole process.
Makes sense. Less clutter on the dashboard too, I bet.
Definitely.
Question 7. Which method is used to assign an alert to a specific support group automatically? The answer is B. Set the alert assignment rule. Why automate this? What's the game?
Speed, mostly.
Yeah.
And accuracy. Alert assignment rules let you set up logic, like if the alert is about a database CI, assign it to the DBA group.
No.
Or if it's severity 1 and impacts the trading application, assign it to the Tier 3 apps team.
So it cuts out the middleman. No one has to manually look at the alert and decide who gets it.
Right. It bypasses that manual triage step. The alert goes straight to the team with the right skills based on criteria defined as CI, the severity, keywords, whatever.
And that means faster response.
Absolutely. Less delay, less chance of it going to the wrong team first. Gets the right eyes on it quicker, which usually means faster resolution.
Like an intelligent dispatcher for IT problems?
It's an analogy, yeah.
Okay. Question 8 is about integration. What information is required for a custom event source to send events to ServiceNow via REST? Answer C, authentication token and endpoint URL. Why these two specifically?
Okay, think of sending a secure message. The endpoint URL, that's the specific web address on your ServiceNow instance that's set up to receive these event messages via the REST API.
The destination address.
Exactly. Without the right address, the message goes nowhere. The authentication token, that's like the secret password or the security key.
Proof of identity?
Precisely. ServiceNow needs to know that the system sending the event is actually allowed to do so. It verifies the sender is legitimate and trusted. It's crucial for security.
So URL is where to send it. Token is proof you're allowed to send it.
You got it. Both are essential for that secure, reliable communication channel.
Makes sense. Question 9. Which configuration element ensures different severity events generate distinct alerts? The answer here is C, message key. How does a message key achieve this separation?
The message key is basically a unique fingerprint for an event occurrence. When an event comes in, the system looks at the message key and the associated CI.
Okay.
If another event comes in later for the same CI, but it has a different message key, maybe because the severity level changed or some other detail is different, the system treats it as a brand new, distinct event.
And generates a new alert.
And generates a new alert? Exactly. This stops, say, a critical event being just an update to an existing low-priority warning alert.
So if my server disk goes from warning 80% full to critical, 95% full. Using different message keys ensures I get a new high priority alert for the critical state, not just updating the old warning.
That's the idea, yes.
Yeah.
It ensures that distinct conditions, especially changes in severity, get the distinct attention they require. You don't want critical alerts getting lost.
Got it. Important for prioritization. Okay, last one, question 10. What does the acknowledge button in the alert console do? Answer B. Assigns the alert to the current user without changing state. So clicking acknowledge doesn't fix anything. What's the point?
Yeah, it
Okay.
doesn't fix it. The point is team coordination. When someone on the operations team clicks acknowledge, they're essentially raising their hand and saying, I've seen this. I'm taking ownership of the initial look.
Okay.
The system then assigns the alert to that user. So everyone else looking at the console knows that person is now handling the initial investigation.
So it stops two people from jumping on the same alert.
Exactly. It prevents duplicated effort. It provides visibility. Who's looking into this right now? Doesn't mean the problem is solved, the alert state stays open or whatever it was, but it clarifies responsibility for that next step.
Right, it's a workflow thing. I'm on it.
Precisely. Fosters accountability, helps manage the workload across the team.
Okay, so here's something to think about as we wrap up. How could really leaning into these concepts, better correlation, solid baselining, clear service mapping, how could that fundamentally change how your IT team operates day to day? What current chaos could you eliminate? What efficiencies are waiting just under the surface? Something to chew on. Thanks for joining us for this deep dive.